Alright, so in this video we're going to look at electrical energy and power. Electrical energy and power. So what is electrical energy? Electrical energy is the work done when a quantity of charge moves between 2 points of potential differences. Electrical energy is the work done when a quantity of charge moves between 2 points of potential difference. Right? So if we take a look at this diagram, we have point A and point B. Right? So the work done in moving a unit charge, so let's say this is a positive charge, right? The work done in moving this charge from this point to point B, right? The work done in moving this positive charge from this point A to point B is referred to as what? The electrical energy. So again, electrical energy is the work done, right, when a quantity of charge moves between 2 points. The work done when a quantity of charge moves between 2 points of potential differences. It's very important that you should know that electrical energy is measured in joules, right? It has the same unit as work done, right? So electrical energy, which is the work done, is equal to Q times V. It is equal to charge times what? The potential difference. So electrical energy, which is the work done, is equal to what? Charge times what? The potential difference. So your W here represents the work done, Q is the charge, while V is what? The potential difference, right? So this formula is very important. So this is one of the formula that we can use to calculate work done or electrical energy, right? So from our previous video, we know that Q is equal to what? IT. Q is equal to current times time. Quantity of electricity or quantity of charge is equal to what? Current times time. So if I put the value of Q, which is IT, into this formula, if I represent this Q with IT, my work done will be equal to IT, which is my Q, times what? Times V. So I can rearrange this and write it as work done is equal to what? IVT. So this is one of the formula that we can use to calculate work done or electrical energy, right? So this formula is very important. W is equal to IVT. Then another formula that we can use is W is equal to I square ROT. And how did we get this? W is equal to I square ROT. So I know that ordinarily work done is equal to what? QV, right? Work done is equal to QV. And from here we deduce that work done can be equal to what? IVT, right? Work done can be equal to IVT. So we know that from Ohm's law that V is equal to what? IR, right? V is equal to IR. This is from Ohm's law, right? V is equal to IR. V is equal to IR. So if I should replace this V that I have here with this IR, what I'm going to have is W is equal to I times this V, and my V is what? V is IR from Ohm's law. So that will be IR times what? Times T. So if I multiply this, I times I will give me what? I square R what? T, right? So my work done is equal to I square ROT. So this formula is very important. So again, electrical energy is the work done when a quantity of charge moves between 2 points of potential differences. It is measured in what? In joules. So the formula is W is equal to QV, or the formula is W is equal to IVT, or the formula is W is equal to I square ROT. So these three formulas are very, very important, right? So next we're going to look at this question.